Okay, so this is 6.46 here, and we're given a truss structure, which I've redrawn here. There's a pin joint at A, and there's a roller joint at E. So I've taken those off and drawn the reaction forces. So we have AY pointed up and AX here for the pin joint. Because at point E it's only a roller, it doesn't have a force in the X direction, it just has EY. And then we have these external forces here, 4 kilonewtons, 8 kilonewtons, and 5 kilonewtons. Okay, and what we're trying to find, we're not trying to find all the forces and all the members. We just have a select few that we're trying to find. We're trying to find BC here, CH, GH, and CG. Okay, so we're going to break this problem down into parts here. The first step I always think is a good starting point is to find the reactions. So find all these reactions at the supports here. Part two, we can use the method of sections. As you see, BC, CH, and GH all line up here. So we could break this truss down here, just down this line here, and expose those internal forces and use the method of sections to figure out these three. And then last, use the method of joints then to figure out CG. All right, and that should solve the problem. So let's get started with finding the reactions. All right, and we have, when analyzing this whole structure here, we have the equations of equilibrium. So let's use the X direction first, and I think that's the easiest. So we're just going to take the sum of the forces in the X direction and set those equal to 0. As you see here, we only have one force in the X direction, which is AX. So we just have AX is equal to 0. So we know that AX is equal to 0. All right, now let's work on finding AY here. And to find AY, we can take the moments around E, all right? EY will not contribute to a moment around E because the force is going directly through it. That way we only have one unknown in this equation, AY, and it should make it directly solvable here. So let's take the moments around E and set those equal to 0, and we'll call counterclockwise positive. All right, let's start with AY. AY was going to create a clockwise moment around E, so that should be negative. AY, and the distance it's acting away is 4 plus 4 plus 4 plus 4, which is 16. And then we'll move down the line here. So we'll have the 4 kilonewton force. That's going to create a counterclockwise moment, which should be positive there. And the distance it's acting away is 12. And then 8 counterclockwise. And that is acting a distance of 8 away. And then we have 5 kilonewtons acting a distance of 4 meters away. And all those should be equal to 0. And solving that equation, we should have AY is equal to 8.25 kilonewtons. Okay. Now if we want to go and find EY, I think the easiest is taking the sum of the forces in the Y direction and setting those equal to 0. Okay, so we have AY pointed up, which we found is 8.25. Then we have 4 4 downward, 8 downward, and 5 downward. And adding all those together, that's 12 plus 5. That looks like it's 17 total downward plus EY equals 0. All right, so let's do that quick calculation here. We have 17 minus 8.25, and that sets EY equal to 8.75 kilonewtons. Okay, so continuing on 646, we found the reactions here. AY is 8.25, AX0, EY 8.75. So in the next step, we want to use the method of sections to find these three forces, FBC, FCH, and FGH, okay? And we can do that by cutting this truss right down this line here, and then only using one section of it. We can either use the right section or left section. I'm going to choose to use the left section here. So we'll use the left section. So let's cut that and I'll show you what it looks like here. Okay, so we've cut it down here and it exposes these internal forces. We have FGH, FCH, and FBC here, and the dimensions are given here. And so what I worked out is kind of the angles of FGH and FCH here. So FGH, we see it goes over 4 and up 2. That makes the hypotenuse the square root of 20. And FCH, we have a 3, 4, 5 triangle here. And that's going to help us in the next step. All right, so analyzing this section here, we have, we can really choose to do anything we want here, whether that's taking the moments or summing the forces. I think the easiest first step is summing the moments around H and setting those equal to 0 and calling counterclockwise positive. So why H? Well, H has two forces directly pointing from it here, this FGH and FCH. These two forces will not create a moment around H and therefore will not be in this equation here. So the only unknown in this equation is FBC, which makes it directly solvable instead of solving a system of equations. So let's do that. So taking the moments around H, we have FBC, which is going to create a counterclockwise moment around H. So we have FBC, and the distance from H to B here, that is 3 meters. So 3 meters. And then we have AY over here, which is going to create a clockwise moment, which is going to be negative. So that's 8.25. And the perpendicular distance from H to A here is 4 meters. So doing that, setting that equal to 0, we come out FBC is equal to 11.0 kilonewtons, and that is in tension. That's a positive number, so that's in tension. And that's one of the answers that we need for this problem. Okay. Now we need to work on finding these other two forces that we have not yet found. I think we can take the sum of the moments around C and set those equal to 0. Now, even though we've cut C off of our diagram here, we can take the moments around C if we wish, and the equations still work out how they should. We can take the moments around some arbitrary point that's not one of the dedicated points in the problem, and it would still work out, even though the equations may be a little complex. So let's do that. Sum of the moments around C, and FBC and FCH both pass through C, so they're not going to create a moment around C. Okay, so FGH is going to have a vertical component and a horizontal component, which are both going to create a moment around C here. So we have FGH. Let's do the vertical component first. And we see the vertical here is 2. We have 2 over the hypotenuse, which is square root of 20. All right, so that's for the vertical component, and that distance, that perpendicular distance here is 4. All right, and let's make sure we have the sign right. That's going to create a, let's see, around C here, that the vertical component is going to create a clockwise moment. I'll have that right. So that's going to be negative. And then we have the horizontal component of FGH, which is then going to create also a clockwise moment, which is going to be negative. So FGH. And the horizontal component of that force is 4 divided by the square root of 20. Okay. And the distance that is away from C to H is 3, this 3 here. Okay. So that should be it for FGH. We need to take into account 4 here. In our moments around H, 4 was actually passing right through H, so we didn't need to account for that. But now we need to, because C is over here, and that's going to create a counterclockwise moment, so that's going to be positive. So we have 4 kilonewtons, and it's acting a distance away of 4 meters. And then we need to take into account AY here. So AY is 8.25, and it's going to create a clockwise moment, so it should be negative here. So 8.25, and the distance it's acting away is 8. Okay, and setting that equal to 0. Now we should be able to solve that, and FGH comes out to be 11.2 kilonewtons, and that should be, it actually comes out to be negative here, and that indicates that it's in compression, so we have 11.2 kilonewtons in compression. And that's one of the answers that we need. Okay, and for the last one, we need to figure out FCH. And I think the easiest way to do that is just take the sum of the forces in the y direction. And we already know a lot of these things here, so we can start with our 8.25 up, positive 8.25. We have negative 4 downward. And then we have FCH here, which is going to be negative. And I have drawn out what component of that it is. So the vertical is 3 over the hypotenuse, which is 5. And then we need to have FGH and FGH. And the component of that, FGH, we have the vertical is 2 over the square root of 20. Square root of 20 here. All right, so did we get them all? Yeah, I think we got them all. And set this equal to 0. I maybe rounded a little too early on this part of the problem. We would actually put in to FGH negative 11.18. That's the more precise before I rounded here. Put that in, and we come out FCH is equal to, let's see here, 1.25. Make sure I get this right. It actually turns out to be negative 1.25 kilonewtons, which is 1.25 kilonewtons in compression. Okay, for the last part of 646, we've already figured out these 3 forces here, but the problem's also asking for FCG. So we figured out these 3 forces using the method of sections. We're going to use the method of joints to find out FCG from here. Now, to figure this out, we could either select joint C or joint G. I chose joint G because it has the fewest number of unknowns. As you can see here, if we chose joint C, we would have these 2 members plus the one that we're trying to find. We have 3 total members that we would need to find to solve this problem. Now if I just choose joint G, I already know GH and I'm looking for CG, and GF is just one that I can solve for, but it minimizes the amount of equations that we have. So I drew out joint G. I have the kind of angles that these forces are pointed here, and I put in FGH, the one we know already is negative 11.18 without the rounding, so I didn't round that. So let's just do the sum of the forces in the x direction and set those equal to 0. So GH, we have, it would be a negative direction because the arrow is pointed negative. So we had FGH, and then the component of that horizontally is 4 over square root of 20 divided by square root of 20. Okay, and then FGF, we have plus FGF, and the horizontal component of that is also 4 over square root of 20, and that is equal to 0. Okay, so we could put in negative 11.18 here for FGH, but you can also see that this is symmetric, and what you'll find out is FGF is equal to FGH if you solve this equation. So FGF, what the unknown we have, is equal to negative 11.18 here, kilonewtons. Okay, so moving on. Now we can just take the sum of the forces in the y direction and set those equal to 0. So in the y direction, all three of these are going to have components in the y direction. So we have negative FGH, and the y component is 2 divided by square root of 20. We have FCG, and then FGF, and the component of that is 2 over square root of 20. All right, and set that equal to 0. And solving that equation, all right, we put in both for these negative 11.18, and this one's also negative 11.18. And solving, we have FCG is equal to 10.0 kilonewtons, and that's a positive number, so that is in tension. And there we have all 4 of the forces we were looking for.